Okay, this is a demonstration of how to do a two-factor ANOVA without replication in Excel. And this is Excel's name for repeated measures ANOVA. I know that sounds weird that it's without replication, but it's a repeated measures. But this refers to that you just have one group, but with multiple measurements. So if you had with replication, you'd have multiple groups of subjects that are independent of each other. Here you just have one group, but there's multiple measurements. It's still a two-way instead of a one-way, though, because you still technically have two independent variables. In this case, we're looking at an example of depression scores for 25 subjects. This should look familiar from the PowerPoint recording. 25 subjects, each with depression severity scores measured at week 0, week 3, 6, 9, and 12. Week 0 being before an earthquake occurred, and then 3, 6, 9, and 12 weeks after. So here I have, the two independent variables are, one is the week, whether it's week 0, 3, 6, 9, or 12. And then the next independent variable is actually the subject, whether you're talking about subject 1, 2, 3, 4, 5. So there's actually 25 levels to that independent variable. Okay, now this is conceptualized. I think it's easiest to conceptualize this as being most similar to a one-way ANOVA, though, because, for example, you're not really interested in interaction for this one, and it's really kind of like a matched pairs t-test versus a independent samples t-test, a two-sample t-test. You're just dealing with more means than just two. So this repeated measures ANOVA, the two-factor ANOVA without replication, is basically like a matched pairs t-test, except you've got more means than just two. Okay, and the calculations are different, of course, but that's the best way to think about it conceptually. Okay, so I've repeated all the data here. And I've just computed the averages just to show where those came from here. And to run this, you're going to go to the Data Analysis Toolpack. Remember, or review how to install this if it's not, or add this, activate this add-in. So you're going to do ANOVA two-factor without replication. Okay. Now, just so you know, if you hit with replication, it's going to be asking for rows per sample, okay? And hopefully, if that will be kind of a red flag that you're in the wrong place, because it doesn't really need to. Here you just have one sample, okay? So you don't really have to tell it how many rows go with each sample. You're just going to select the whole thing. So hopefully that can clue you in, oh, you're in the wrong place if you're running this type of analysis. So we want without replication, and we're going to select the input range of these numbers. Notice I didn't select, oh, excuse me, I actually do want to select those. You do want to select the labels at the top, and then the labels for each row, if you have those, you want to select those too. Okay. Otherwise, your numbers will, well, if you do select that and check labels, then you're good. If you check labels and you don't select this, then you can be in bad shape. Okay, so you've got labels here on top for each column. You've also got labels here on the side for each row, and you want to select all of it. Okay. And then you're going to, I'm going to select an output range of this cell right here, and we'll hit OK. And it's as simple as that. The output has quite a bit to it. You can see here's our averages repeated here, so that's good for peace of mind. Here you can see our averages here. So these are just some descriptive statistics that are put in here at the top. And then here's the meat of what we really want, this output. Okay. So you've got the sources of variation here, the sum of squares for the rows. So this is the variability attributed to the subjects, differences between subjects, this is the variability attributed to the different weeks, the 5 different weeks. Okay, and this is what we're really interested in, is the variability attributed to weeks, because, and I probably should have mentioned this before, our null hypothesis is that these 5 means right here, the null hypothesis is that they're all the same. Okay, null hypothesis is that all the means are the same. Hopefully that sounds familiar. That's very similar to what we talked about with or this is the same kind of null hypothesis you would have for a one-way ANOVA. An alternative hypothesis is that at least one of the means is different from some other one. And we have a sufficiently large F statistic right here that's 6.4, and a sufficiently small p-value to reject the null hypothesis. Okay, so we would say at least one of these means are different. And there are some post hoc multiple comparisons tests that you can do afterwards to see where that difference is. These other 2 statistics you really won't use much, and in fact, sometimes these numbers aren't even given to you in the output. If you look in the textbook, which the data is referenced in the textbook as well, this F statistic isn't even provided. This is basically saying here there's a main effect. If you want to use that language, there's a main effect of week. Okay, here, so there's a significant main effect of week. There is also a significant main effect of subject, but we don't really care about that so much. It's basically saying that the subjects are different, but that would be very strange if they weren't different, if they were all exactly the same, with all the same levels of depression severity. So yes, it's significant, but nobody really cares. And then the error, this is actually the interaction between these 2, and it doesn't even provide you with an F here. This is really kind of just calculated to be able to give you this, to give you the proper denominator that, excuse me, to calculate this mean square for the columns. So this is really what you're after, this F statistic and this p-value, and here's one last little thing just to illustrate. Remember that I said it's easiest to kind of conceptualize this as being similar to a one-way ANOVA, except you're taking into account the fact that you're taking repeated measures on each subject. So basically this allows you, you're accounting for the differences, the individual variability in your sample. You're taking into account the fact that subjects, hopefully, or your hypothesis is that they're changing from week to week, but you're also taking into account the fact that they're going to be different even from the start, even from a baseline. Okay, so here is that same output I've done here, just repeated, and then this is the wrong way to do it, but this would be the single factor ANOVA, and you can see it ends up quite differently. So the single factor, you'd select all these means, and you just basically compute to see if there's a difference in between any of them, and you can see it's not significant in this case. So that's it pays off to take into account that variability. Okay, so that's how you do it in Excel. Relatively straightforward. Just remember, you'll want to use this type of ANOVA if you have related data here. So, here's subject 1 and here's the multiple measurements on that subject. You wouldn't want to take column 12 or column F for week 12 and just shuffle all these numbers up, because then you would be confused as to which number goes with which subject. So these are data that are related. They're dependent on each other. These means are dependent on each other, and so you would want to use this repeated measures test instead of the one-way ANOVA. Okay.